In this video, we will be looking at 2D and 3D trigonometry. But before we do that, there is some angle notation I want to go over. So the first one is about headings, and these are when your angles are given with reference to north or south and going in the direction of east or west. So for example, when we look at the first one, the heading is north 65 degrees east. This just means you're going to start in the north position, so right here, north, east, south, west, and you're going to go 65 degrees towards the east. And the next one we have south 40 degrees west, meaning I'm going to start in the south direction and move 40 degrees towards the left because that's the west direction, which means the person or object is moving in this direction here. And finally, south 30 degrees east. We start south, so we're using south as our reference line, and then going to the right 30 degrees for our actual direction. So you do have to remember your north, east, south, west, and then you will always start with the north or south depending on what the first letter is, and then you will go to the right or left to form your angle and your direction depending on if it says east or west. So those are headings, but you can also be given a bearing, and a bearing is an angle that starts from north going in the clockwise direction. So if a bearing is given to you, it can be anywhere from 0 to 360 degrees, like a full rotation. So if we're given a bearing of 45 degrees, I know normally when you look at a regular Cartesian grid, when we were doing solving trig equations, 0 was the positive x-axis, then 90, 180, 270, 360. But that does not apply for bearings. So not to this. So when you're dealing with bearings, north becomes your 0 degrees. And then you have 90, 180, 270, and then a full 360 is north again. So if I want to go 45 degrees from north, I will be somewhere here in quadrant 1. And then if it's a bearing of 130 degrees, I start at north, which is 0. One quadrant is 90 degrees, so I have to go a little bit past that. So here is my direction. So we're actually 40 degrees into quadrant 4. Sometimes you will have a turn or a change in direction. So when there is a change in direction, you should continue the current path and then turn in that specific direction however many degrees. So let's say you are walking and you turn 25 degrees. If this is your current path, when you turn 25 degrees, you have to turn 25 degrees assuming your continued path. So 25 degrees to the right of this path tells me this is my turned direction. All right, now that we have a little bit of side knowledge on angle notation, bearings, headings, and that kind of thing, let's do some 2D trigonometry first, and then we'll look at some 3D scenarios. And the trick to all of these is drawing your original diagram so that you can use your prior knowledge of SOHCAHTOA, sine law, and cosine law. So for our first one, James stood at a distance admiring a magnificent Douglas fir. James measured the angle of elevation to the top of the tree and found it to be 15 degrees. James then walked 31.4 feet closer to the tree, and this time the angle of elevation to the top of the tree was 17 degrees. Calculate the height of the tree to the nearest tenth of a meter. Okay, so here is our tree, let's say. And the first time that James looks up at the tree, let's say he's here, I'll just call that James 1. His angle of elevation is 15 degrees. But then he walks closer to the tree. So let's say he's here. I'll just label that James 2. He looks up at the tree and he is now at an angle of elevation of 17 degrees. I know that there must be a right angle there, and the distance that he walked was 31.4 feet. And our goal is to find the height of the tree to the nearest tenth. So I'll just label that h because that is my goal. Now, looking at this, I see a few different triangles. I have a triangle here that is oblique. I have a little right triangle here, and I have a big right triangle here. Now, I do not have enough information in either of my right triangles. I need to find a side length. So that is my first goal, which means my first step is going to be to use this oblique triangle, which means I will use sine law or cosine law. Now, before I do that, there are some missing angles here, and I know I can solve for them. If this angle here is 17, this angle must be supplementary. So if I do 180 subtract 17, I will get that angle. So that angle there is going to be 163 degrees. And then I know all three angles in a triangle should add up to 180. So to find this little angle at the top, I can do 180 subtract 163 subtract 15, and I get 2 degrees. Now that I have all of my angles, I see I have a full pair because opposite angle 2 degrees is this distance of 31.4 feet. And then I can choose. I can either solve for this side length here, and then I can use the right triangle to find the height, or I can solve for this long height here, or this distance, and then use the big right triangle. I personally will use this. So I'm just going to label that x. And now I'm going to do a sine law. So x matches the 15 degrees. They are opposite. They are that full pair. So let's set up our sine law. Sine of 2 degrees over the opposite side, so 31.4, equals sine of 15 degrees over x. And now we can cross multiply. X times sine 2 equals 31.4 times sine 15. And then we can divide both sides by sine 2 because we are trying to isolate for x. And then this is what you will plug into your calculator. And when you plug that into your calculator, you get approximately 232.87 feet. Now, I know that the question said round to the nearest tenth, but that is my end goal. So any calculation I do beforehand, I will round to 2 decimals or more, just to maintain a little bit of accuracy. Okay, now that I know what x is, so I'll just go in and label that. Now, looking at just the right triangle here, the right triangle means I'm probably going to do SOHCAHTOA just to make my life easier because I'm allowed to do SOHCAHTOA in a right triangle. 17 degrees is my reference angle. The height that I'm looking for is opposite. The x that I found is my hypotenuse, and the blank side is adjacent. So if I'm looking for opposite and I'm given hypotenuse, that means I will use sine for my second calculation. But just sine, not sine law. So sine 17 equals opposite, which is the height, over the hypotenuse, which is what we just calculated. And then we'll just put sine 17 over 1 and do a nice quick cross multiplication. So in your calculator, you will be multiplying the answer you just got by sine of 17. And you should get approximately 68.1. And here I will round to the desired number of decimals. And now we can write our therefore statement. Therefore, the tree is 68.1 feet tall. All right, let's try the next one. 2 ships left Port Hope on Lake Ontario at the same time. One traveled at 12 kilometers per hour on a course of 235 degrees. The other traveled at 15 kilometers per hour on a course of 105 degrees. So those 2 angles, those are bearings that we talked about earlier. How far apart were the ships after 4 hours to the nearest kilometer? All right, so first of all, maybe we want to calculate how much each ship has traveled in 4 hours. So this first ship here, it traveled 12 kilometers per hour for 4 hours. So 1 hour is 12 kilometers, 2 would be double that, etc. So I just have to multiply the speed by the time. So 12 times 4 is 48. So 48 kilometers for the first ship. And then the second ship, 15 kilometers per hour for 4 hours. That will be 60 kilometers. And I need to calculate this so that I can label those side lengths once I do my little diagram. So for my diagram, I'm gonna put this little grid here because I really need a visual. I know the 2 angles that were given to me start from north, and north is at the top. That is 0 degrees. Maybe you want to do a little reference angle for you. So this is 0, this is 90, this is 180, 270, and then a full 360 back at the top. The first ship was on a course of 235 degrees. That means we're somewhere between 180 and 270. Okay, so that's ship A. And we were told, or we just calculated, that it was 48 kilometers. So this angle here is 235 degrees. Ship B is on a course of 105 degrees, so it's going to be between the 90 and the 180. So let's say here, and it traveled 60 kilometers. So that's this angle right here. Now, neither of those angles are actually inside my triangle. Actually, let me create my triangle first. So I'm just going to connect A and B. My goal is to find the distance, so I'll just label it D, between those 2 ships. So I have 2 side lengths, and currently I have no angles, okay? But I do know that this angle here is 235 degrees, and this portion is 105. So if I just subtract this 105 from 235, I'll get this inside leftover angle. So 235 subtract 105 gives us 130 degrees. So that goes right in here. And now I have a diagram. I have 2 sides and 1 angle, and that angle is actually contained between the 2 sides, so it should look like that duck formation that we always use in cosine law. So let's use cosine law. We're looking for D, so it's going to be D squared equals the other 2 sides squared minus double the other 2 sides, and then cos of the angle opposite the side we're looking for, so cos 130. And then we can plug that right side into our calculator all at once, and you get about 9,606.456632. Now obviously this is not the distance. We have to remember we have to square root both sides. So the actual distance is approximately 98 kilometers, and I did round to the nearest kilometer because that's what the question said. Therefore, the ships are 98 kilometers apart. All right, our next 2D scenario. Daniel begins his sailing trip by traveling at 50 kilometers per hour for 2 hours in the direction of south 20 degrees west. So 50 kilometers per hour for 2 hours, that's 100 kilometers in total. He then turns right and travels at 40 kilometers per hour for 3 hours in the direction north 15 degrees west. So 40 kilometers for 3 hours, that's 120 kilometers. Just 40 times 3. So let's get a visual going. They do ask us for the first part, determine the distance between his current position and his starting point. Now, having a very clear somewhat accurate visual will be very important for this type of bearing scenario since there is this change in direction. So I'm going to start, well, his first move is that he's going in the direction south, 20 degrees west. So I'm just going to put a little grid here. So south is down here, west is here. I want to be 20 degrees, so to the left of south. So that is the first move, and this is the starting position. So 20 is over here. And then once he reaches this point, there's a change in direction. So I'm going to put another little grid for myself. And this time it's going north 15 degrees west. So north is the top, and we want to go 15 degrees to the west. So north is here, west is here. We're going to go like this. And this right here is 15 degrees, just that little section. Now I already know the distances. So 100 kilometers in the first segment, and then 120 kilometers in the second segment. Okay, and that will create a triangle for us. So this is the start, this is the current position, I'll just call it end. We want to find the distance between the two. So this is our goal. But right now, yes, I have two side lengths, but I don't know any angles. So I do have to think back to my grade 9 angle rules. So these grids here, these little Cartesian grids I put for north, south, east, west, they're parallel to each other. So this north-south line is parallel to this north-south line, which means if I do a little Z pattern here, those middle angles are alternate angles. So this here, that tiny portion, is also 20 degrees. So now I have 20 degrees on the right, 15 degrees on the left, which makes this entire angle 35 degrees. Now I have two sides and the contained angle, and I can do another cosine law to find the distance between his current position and starting position. So I'm going to go ahead and do that. If you'd like, pause the video here to set up your cosine law and solve for that distance. But we will have distance squared equals the other two sides squared minus double the other two sides times cos of that contained angle. When we put that into our calculator, we get approximately 4,740.350937. Now, you don't have to write all those decimals, but definitely keep them all in your calculator and just take the square root of all those decimals just to keep the accuracy. So here, 68.85. I'm just going to keep two decimals. It didn't specify how many to keep, so I'll keep 2 because I do have to do more calculations in the next part, so I might as well keep it a little bit accurate. So therefore, the distance between his current and starting position is 68.85 kilometers. All right, part B. Determine in what direction he should travel to get back to his starting point. So this is the end point here, and I'm just going to put another north, south, east, west. They're pretty much asking me to find one of these angles so I can figure out how to get back to the start. So if this is his end and he's trying to get back to the start, I need to find the angle of this line. And our angle is always starting from either north or south. So really, this is my goal, the angle from south to that green line. Now, let's see if we know any angles already. I can do another Z pattern. So this line here is parallel to this line. So if I do a Z pattern with the 15 degrees, then this middle angle here is 15 degrees as well. So I just need to calculate, I'll label this X, that angle, and then I can add the two angles together to actually get my heading. Now looking at what I have, I'm going to go ahead and fill in my distance. And I have a full pair between the 35 degrees and that distance. I have 100 kilometers and I'm looking for X, which is opposite. So perfect, I can do a quick sine law. So sine 35 over the 68.85 equals sine X over 100. I'm going to cross multiply here so that I get 68.85 times sine X equals 100 times sine 35. I have run out of space a little bit, but you should be working vertically. So I do need to get rid of the 68.85. Don't divide out the sine. The sine is attached to the X because X is the angle. So I'm just dividing both sides by 68.85 and that cancels them out and you're left with sine X on the left side. So if we actually want to find angle X, you're going to have to take the sine inverse of this entire fraction that we have on the right side. And when you plug that into your calculator, you should get approximately 56 degrees for X. So if we have 15 degrees here, 56 degrees here, when we add those up, that's 71 degrees. So that means the bearing is going to be starting from the south, and then 15 plus 56 is 71, going towards the east. So this here is the heading. We should write it as a therefore statement, but I've run out of space. So therefore, he should travel south 71 degrees east. So the actual trigonometry skills you should have from before, just the diagrams are slightly different just because of those bearings and headings. Now, let's move on to some 3D diagrams. Malika leaves her house and walks 850 meters to the local gelato place. After buying a gelato, she turns right through an angle of 120 degrees and walks up a hill with an angle of elevation of 20 degrees to reach the music store. At this point, she has walked a total distance of 1,500 meters. If there is a direct and well-worn path from the music store back to Malika's house, determine how far it is and what the angle of depression would be. Now, we have to visualize this in a three-dimensional space. What I want you to visualize is the corner of a box. And that is what I'm going to draw. Okay, so imagine this is the corner of a box and a piece has cut off, so you have this triangular region at the front, an empty space. Okay, this point is above ground and this base is kind of ground level, the elevation 0, let's say. So I'm gonna say that Malika and her house right here. She walks to the gelato place, which is here, and it's 850 meters away. Now she's gonna walk up a hill. So before I even do any angles, I just want to explain the visual. So she walks right here. Then imagine this is the hill. Now it's obviously very steep. It's more just for the visual, or the ease of drawing it. So she walks around her house to the gelato. Okay. Then she goes up this hill, and this is her coming down the hill. This here, that's not a street. This is just the the elevation, like the height of the hill to regular ground level. So this is her actual path. Now you have to imagine that this part though is the slanted portion of the hill. And they do tell us that the angle of elevation to the music store, so the angle of the hill is 20 degrees. So I'm actually going to put the 20 degrees right in there. Okay. And they also tell us that once she reaches the music store, so M for music store, she has traveled a total of 1,500 meters. So she's already traveled 850 to the gelato store, which means 1,500 subtract 850, that's 650 meters from the gelato store to the music store. Okay, and our goal is to determine how far she is from her house, so I'll label that X, and the angle of depression from the music store to her house. So you kind of have to imagine there's this horizontal line here, and if I Z pattern it from here down here, this is the angle in the triangle that I actually want. And I'm just going to label that theta. So those are my two goals. Now I'm going to have to solve for a lot of things along the way to get there, but there it is. Now there is one more piece of information that I missed to label, and that's the turn that she made. When she gets to the gelato, she turns right through an angle of 120 degrees. So remembering from the very first page, when someone is turning, you have to first imagine their regular path. So this is the regular path if she walked past the gelato store, but she turns 120 degrees so that she can then climb up the hill to the music store. Now you do have to remember what ground level is, and the bottom of triangle represents ground level. This here, that's ground level here. This part is the elevated, up the mountain, down the mountain. Okay, so when she turns 120 degrees, the 120 degrees goes to ground level. We're ignoring the hill altogether. The hill has nothing to do with our 120. So this angle here is supplementary to 120. So 180 subtract 120 is 60 degrees. So you do have to really visualize the 3D side of this. This part here is laying on your desk. It's a piece of paper on your desk. This part here is the raised portion. Imagine a hill from your table. Okay, so when the turn is made, it has nothing to do with the hill just yet. Then you go up the hill, and now we need to go down the hill. So when we look at the three triangles that we have in front of us, these two are right triangles, so I can do SOHCAHTOA in them, but this base triangle here is not. Okay, so here we cannot do SOHCAHTOA. So we do have to find a few things. My end goal is this and this. Well, in order for me to find the angle, I need two sides. In order for me to find the side length here, the hypotenuse, I either need two sides to do Pythagorean theorem, or I need an angle. Either way, I need to figure out these two. I need to know what those dimensions are, or else I can't really get anywhere. So this is going to be my first goal. I'm going to label it A. And I know I can solve that because I can work inside this right triangle and do a SOHCAHTOA. Now to solve for this, I have to work in my oblique triangle. And all I have in this triangle is one angle, one side. That is not enough to do sine law or cosine law, which means I actually have to solve for this as well, because then I'll have that little alligator mouth and I can do cosine law to solve for this. So quite a few steps to do. So A will be step 1, B is step 2, C will be the third step, and then we can actually find what we're actually looking for. So for A, we're going to use 20 degrees as our reference angle. A is opposite, 650 is hypotenuse, and B is adjacent. So I'm looking for opposite first, and I have the hypotenuse, so that is sine. So sine of 20 degrees, that elevation angle, because we are looking at the hill portion of this diagram, equals A over 650. Now we can cross multiply, and we will multiply 650 with sine 20. And that will give us approximately 222.3 meters. For B, I'm still going to use the hypotenuse because that I know for sure is correct. So now I'm looking for adjacent, and I have hypotenuse, so I'll use cos now. Cos 20 equals B, adjacent, over hypotenuse 650. Once again, cross multiply. Only difference, we're now using cos instead of sine. Go to our calculator once more, and we get 610.8 meters. And try those out in your calculator to make sure you're plugging things in correctly. Also, make sure you are in degree mode and have been in degree mode this entire lesson. Okay, great. I found A and B. Now I want to find C, because then I can find my goals. So, because I do have B now, which I'm not going to label in my triangle because it's kind of squished in there, I do have these two side lengths and the contained angle. So, once again, we will do our cosine law. So I'm looking for C, so that will be C squared equals the other two sides squared plus 610.8 squared minus double the other two sides times cos of that contained angle of 60. Now you can plug that into your calculator and you will get 576,396.64, and then don't forget to square root both sides because that number does not make sense in this scenario, and you should get 759.2 meters. Okay, great. So now I have information I care about. So A was 223.3, C was 759.2. All right, to find my angle, I would have to label. So A is still opposite, C is adjacent to theta, and X is hypotenuse. So opposite and adjacent would be tan to find my angle. And then to solve for X, I can either do Pythagorean theorem or do a SOHCAHTOA after I find the angle. Choice is yours. I'll just do a quick Pythagorean theorem here. So because X is the hypotenuse, it'll just be X squared equals the other two sides squared. And when we simplify that, we get 625,801.93. Square root both sides, just like in cosine law, so that we get X is approximately 791.1 meters. So that would be the distance from the music store to her house. And then for the angle, opposite and adjacent is given to us. So that is tan. Opposite is 223.3. Adjacent is 759.2. And you are going to take the tan inverse of this because that is how we get our angles. And if you do that in your calculator, you get 16 degrees. Now, I do need to write a therefore statement, but I've run out of space, so I would just write, therefore, the distance from the music store to her home is 791.1 meters at an angle of depression of 16 degrees. Because remember, this theta here is the same as what the actual angle of depression up here would be. So the visual is very hard just because you have to envision this 2D diagram in a 3-dimensional space. But having that visual of the corner of a box should maybe help you see everything. Let's try another one. And these 3D diagrams will always have that corner layout. The things that are given to us might be slightly different though. But the calculations themselves are familiar. It's just the diagram that is trickier. All right, from the top of her room, 12 meters above the ground, Lisa sees her friends walking towards her home. She sees Ali at an angle of depression of 40 degrees and Marcus at an angle of depression of 24 degrees. Now this right now just sounds like a two-dimensional question where I'm going to erase this, so don't write it, where you have 12 meters here, one person's here, one person's here, and you have a right angle. And you know, an angle of depression there, an angle of depression there, and boom, you're done. However, this next sentence will tell you that it's actually not a two-dimensional question. So I will go ahead and erase this. That's what we normally would have done, maybe in grade 10 or in the two-dimensional questions, but here is the change. With reference to Lisa's building, Ali and Marcus are positioned at south 50 degrees west and south 25 degrees west, respectively, which means they're not directly to the right and directly to the left of Lisa and her room. So you can't imagine everything in a plane, okay, or this two-dimensional space. Our goal, how far apart are Lisa's friends? So here's Lisa up in her room, 12 meters above the ground. Okay, this is ground level here. Her friends are not there. One friend is here. One friend is here. So let's say we have Ali, we have Marcus. Okay, and there we are. Here's the three-dimensional space. Now, the angle of depression to Ali is 40 degrees. So we have to look at this triangle here. And imagine Lisa looking horizontally like this. So this angle on the outside is 40 degrees, but when I do my Z pattern, I can bring it in right here. And same thing with Marcus. Angle of depression is outside the triangle, but we can bring it in right there. All right, the final thing that we require is to deal with this. This is showing the angles that Ali and Marcus are with reference to Lisa's building. This is actually going to give us this angle right here. It's kind of like the viewing angle. If Lisa were to look from Ali to Marcus, there's a certain angle her head is making. Now for us to figure that out, I'm going to put a little side note here with my north, south, east, west. Ali is south, west, so south 50 degrees to the west. So here we are. And then I just realized there's a little typo here for Marcus. It should say south 25 degrees east, so 25 degrees to the east for Marcus. So that would be, if we add these up together, that would be the viewing angle for Lisa to look from Ali to Marcus. So when we add them, that's 75 degrees, and now we can put it inside of our diagram. Okay, now let's see, what are we looking for? How far apart are Lisa's friends? Here's the goal. I will label it D. So in order for me to solve for that, I definitely need to work inside this oblique triangle where I don't know anything except this angle. Now, that being said, that means I am going to have to work inside my right triangles first. So if I look here, I can solve for this, I can solve for this, and then I'll have enough information in the oblique triangle. So I'll start with Ali's triangle. 12 is opposite to 40. The hypotenuse is that blank side, and the side I care about is the adjacent, and let's just label that X and this one Y. So opposite and adjacent, that is tan. So tan 40 degrees equals opposite 12 over adjacent X, and then we can cross multiply. X gets multiplied with tan 40, but obviously I want to isolate for X, so I'm going to divide both sides by tan 40 so they cancel out on the left, and then tan 40 on the right. So 12 divided by tan 40 is what we're plugging into the calculator. You know, pause the video to see if you plug it in correctly, but you should get 14.3 meters for X. So 14.3. And then we'll do the same thing for Y, and 12 is still opposite 24. The blank side is the hypotenuse, and the Y that we care about is adjacent. So we're using tan again. But this time it's tan 24. same cross multiplying, x with tan 24, 1 with 12, which is just 12. Divide out tan 24. And you have to divide out the tan as well because 24 is the angle and it's attached to tan. So we plug that into our calculator, 12 divided by tan 24, and you should get approximately 27.0 meters. So I'll just put that in. Now, if I look at my triangle, I have this side and the contained angle. So it ends up being cosine law for one final time to find that distance. So my distance squared is the 14.3 squared plus the 27.0 squared minus double those distances times cos 75. Now if you didn't get that 75 because using those headings, then there would have been a problem. You wouldn't have had enough information, but we were able to figure it out. So when we plug that right side into our calculator, we end up with 733.629934. Again, not a realistic number. Don't forget to square root both sides, and we end up with 27.1 approximately. And now we can write our therefore statement. Therefore, Lisa's friends are 27.1 meters apart. And that's it for 2D and 3D trigonometry with that angle notation variation.